Hey guys, welcome back from spring break, and today with this video we are going to jump into exponentials. And when we jump into exponentials, we're going to introduce it with the compound interest formula. Now this formula is important. It's going to be on your formula sheet next year for Algebra 1, but it's important that we cover it this year in order to kind of give you guys some extra knowledge going into next year. Now, the compound interest formula. Awesome thing about formulas, if you guys don't remember me talking about it in class, is that formulas always tell you what you need to know. You just kind of got to figure out what's what. So went ahead and outlined it for you yesterday, so hopefully you guys took notes on all that and that you have that in front of you today. But just as a quick refresher, P is the principal amount or the initial amount you're going to borrow or deposit. So this is whatever you're either taking out or you're putting in. Majority of the time it's a deposit that you are putting into the bank account. Then you have your R, which is your annual rate of interest. Now, the thing about that is the R is almost always going to be given to you in the problem as a percentage, but we're going to have to transform that into a decimal, so 0.05 or something of that sort. And we will have to do that every single time no matter what, but we'll jump into that in a little bit. Then we have T, the number of years the amount is deposited or borrowed for. So T is always time. So it's going to tell you the amount of time that things are going to be, the interest is going to accumulate over. And then you have A, which is the amount of money accumulated after N years or just your total amount. And then N is the number of times the interest is compounded per year. So you should have also jotted down all these notes yesterday as well. So these are the different values for N. So annually just means once a year. So therefore N is going to equal 1. Then you have semi-annually. And semi means 2. So N would equal 2. You have quarterly, 4 quarters. So N would be 4. Then you have monthly. Hopefully everybody knows there are 12 months in a year. So N would be equal to 12. And you have daily. There are 365 days in a year. I know there's leap year, but we don't count it. So daily is going to be N equals 365. So that's kind of the introduction to the vocabulary and everything else with this compound interest formula. So the hard part's understanding what all's going on. Then we're going to get into problems, which we're going to get into in just a second on this next slide. And you just kind of got to put everything together. And so let's look at example 1. So Lloyd puts $600 into an account to use for school expenses. The account earns 3% interest, compounded annually. How much will be in the account after 6 years? Now, for this first day, all we're going to work on today is taking the compound interest formula and then identifying the variables. So we should all know that the compound interest formula, because you should have it out in front of you, but just in case, I'll write it over here to the side, is A equals P parentheses 1 plus R. Well, it's supposed to be an R. R over N times N T. So that is your formula. So now we just need to identify A, identify P, identify R, N, and T. And if we can identify all those things, the awesome part is we can just punch those into the calculator. But today, all we're literally going to focus on is just being able to take the word problem, like example 1, and identify the variables. So every single time I do this problem or do these problems, what I like to do is go ahead and write everything out. So A equals, P equals, R equals, N equals, and T equals. So A equals. So remember, A is the total amount. So if you read through this problem, it asks you how much will be in the account after 6 years. Well, how much is represented by money, so it's asking for the total amount of money. So do we know what A is? We do not. That's actually what we're looking for. So I'm going to put a question mark. That's the question. So then we have P, and P is our principal. So if Lloyd puts $600 into an account, that is his initial investment or his principal. So P is going to be represented by 600. And then you have R. R is your rate. So it says the account earns 3% interest. So since R is your rate, we know it's going to be 3%. That's supposed to be a percent sign, guys. Sorry, this pen's a little bigger than my other one, so I struggle writing with it on this small screen. But so we have 3%, and so if we had to convert that into a decimal, all you're going to do is take your percent, which is 3, and you're going to write it over 100, or you're going to divide 3 divided by 100. And if you were to do that, see if my calculator can pull up here. Maybe. Well, brief pause. So hopefully you guys are writing all of this down as my calculator for some reason is not pulling up. Well, either way, I was going to introduce this to you, but not right now. But wasn't planning on doing it right now, but we can go ahead and do it right now. This is the scientific calculator for Desmos, but we can do 3 divided by 100, and it's going to turn that into a decimal, which is 0.03. So if we go back, the 3% is really equal to well, here's my calculator. But we don't need you right now anymore. So we have 0.03 is my new R. So now we have N. And so, excuse me, N is going to be the number of times it's compounded. So this is what's awesome, is it almost always tells you compounded such and such. In this case, it says compounded annually, and we know annually means 1. So N is going to be equal to 1. And then time, well, what number represents time in the problem? And it says it in the last sentence there, and it says how much will be in the account after 6 years. So we know our T is going to be equal to 6. So now that we know that, we can punch that into our formula. So we don't know what A is. So A equals, we do know P is 600 times 1 plus R, which is that 0.03 over N, which is 1, raised to NT. So N is 1, parentheses, 6. And so that's how you would fill those problems in. That's as far as we are going to go today. That's all we're going to practice today, and then we'll practice on solving it and getting our answer tomorrow. So let's look at example 2. So we know the compound interest formula. Hopefully you have it in front of you. But once again, go ahead and write out all your variables. So we have A equals, P equals, R equals, N equals, and T equals. So now as we read the example, we can just fill stuff in. So Harry invests $1,000 into a bank account. So right there, we should stop. He is investing $1,000. So therefore, that is going to be our principal. It is what we are putting into or investing. So therefore, the P we know is going to be 1,000. And the bank compounds interest semi-annually. So once again, we look for that compound word, and that's going to give us our N. and it says semi-annually. So that means the N is going to be 2 at 5%. So R, your rate, is going to be 5%. And we know if we're going to convert that into a decimal, we have 5 over 100. So now we could use our calculator. Do 5 divided by 100, enter, and so it turns it into 0.05. So that's your new R. And then your T is how much money will you have in your account at the end of the year. Well, it doesn't give you a number, but it says at the end of the year. So that means that your T is going to be 1 because it's asking after 1 year. So now you're just going to fill that in. So we know we don't have A. We do have P. It's 1,000. Parentheses 1 plus R, which is 0.05 over N, which is 2, raised to NT, so 2 parentheses 1. And so that's how you would fill it in. Remember, you should already have your formula written down. Went a little too far on my R. And so therefore, once you have them filled out like you do over here on the left, then you can just plug them straight in to your formula on the right. And so hopefully you guys got that. If you guys have any questions with this, please reach out to me. You will not have an assignment today. The assignment will come tomorrow as we begin to solve these. But I just want to give you guys a day of practice on seeing this. I know this video is a little bit long, but this is not a very complex, but as we move into later in the semester, the topics do get a little bit more complex. We are going to go a little bit slower with them. So please, if you have any questions on anything, reach out to me tomorrow before we get to the assignment on Wednesday. So I hope you guys had a great spring break. I miss you guys. If you need anything, please let me know.